All right, what's up, everybody? Hutch here, and this is Module 7, Lesson 6, which is all about writing and solving one-step addition and subtraction inequalities. So this is your first time really doing work with inequalities. Let's go ahead and dive right in. We're still using the same concepts you can see here of the properties of equality, or in this case inequality, that says that if you do the same thing to both sides, it doesn't change the inequality. Okay, specifically when we're doing addition subtraction changes. Now that is a little bit different when we get to multiplication division, but we'll talk about that in the next lesson. So an inequality means that it's not equal. Okay, so that's where you get your less than, greater than, or equal to. Just a reminder, if we have x and this symbol, let's say a 4 here, we always read from left to right, or from wherever the x is, okay? And so from wherever the x is, if this is the bigger side, this is greater than, okay? If I have x over here, and it says this, okay, then this is, if we read from the x, this is x is greater than 4. Okay, so just make sure you're reading from the x and then look at the symbol. So if we have a symbol like this, then from the x, you can see the small side is first. So this is x is less than 4. So always read from the x is my best advice to you when you're doing this. Okay, all right. So we have is less than, greater than, and then this right here, we know means is equal to, okay? But I also want you, for the purpose of this lesson and the next lesson, I want you to think about that as a piece of cement underneath, okay? It means we're going to include that number, okay? So is equal to is what that means. Okay. All right, so let's go ahead and take a look. And here's why I told you to think about that as cement. Okay, so when we're drawing or graphing inequalities, here's the inequality, x is less than 3.5. We always read from the variable, from the x. Okay, and so you can say, see, x is less than means go left. And if there is no cement underneath, you can see it's an open hole like this. It means we're not including the 3.5. Okay, but in contrast, if we do have the cement, this is reading from the x is greater than. So when we are graphing it, we would see this and we go, okay, greater than, but it says or equal to, which means we're including the -1. It's like a hole with cement in it, so we fill that in. So x is greater than or equal to. We're including the -1. Since it's greater than, that arrow goes to the right. Okay, so those are a couple foundational things to be aware of. This is just talking about the subtraction and addition properties of inequality. It's the same as equality. You can see if we subtract 4 to both sides, we still have -2 is less than 1. It's still a true statement. Okay, same thing if we do the same thing to both sides here, we still have a true statement. Okay, so that's why we're allowed to move things around like that. So let's go ahead and practice solving and graphing addition inequalities. So when you do this, it's going to be very similar to what you're used to. Let's go ahead and do a rewrite here. 0.4 plus y is less than or equal to -9.6. Just like before, okay, you're going to separate your workspace. Okay, because we're functioning the same way. We want to get all the variables on one side, all the constants on the other. So obviously y is on the left already, so I'm just going to subtract 0.4 to both sides. Okay, this goes away. Now, the only thing is you're in a habit of writing an equal sign. You need to maintain that inequality. Okay, so let's plot our calculator, and we have same signs add and keep. So we have a 9.6 plus 0.4. They're all negative, and so we have a -10. Okay, all right, so we have y is less than or equal to -10. Now, it does say graph the solution, so I want to teach you how to do that. So I made a little cheat sheet here. So the first thing that you're going to do is draw the line, make 3 tick marks, write the target number, write a number bigger to the right, a number smaller to the left, and then decide whether it's that closed cemented circle or it's an open circle. So let's go ahead and walk through that. It's a pretty simple process, and it doesn't need to be very big. Okay, so I'll do it right here for you. So here's my line. The line has arrows on both sides. I'm going to make the 3 tick marks. 1, 2, 3. Write the target number. My target number is a -10. Okay, that's the number that we see up there. And then write one number bigger to the right. Okay, so just be careful because it's a 0 is way down here. So bigger would be -9, smaller would be -11. You just have to be a little cautious of negatives on a number line. All right, now that we've done that, I'm going to change colors, and it says decide on a closed circle or open circle. Well, if I look at this right here, I have the cement, which means it's going to be a closed circle, okay? Because it says y, we read from the y, okay, read from the variable. Y is less than or equal to. Because it says less than, we're going to go to the left, and you have to really darken it in, okay? And you don't have to go that far, okay? And then -10. And what that means is anything you put in here, as long as it's less than or equal to -10, the statement will be true, okay? So that is how you create the graph for those, okay? All right, let's go ahead and try this one out. Okay, so same thing. Notice it's not or equal to. Separate your workspace. Let's go ahead and isolate the variable. So at least they're nice and easy problems. Just one little twist of new things. That goes away, and you have x is less than 5.4 minus 1.3, 4, 3, 2, 1. So you have 0.1 and you have 4. So 4.1. And now we need to go ahead and graph it. So x, read from the variable, okay? So that would be my other thing for you to remember. So we draw the line. We make 3 tick marks. We write the target number, which is 4.1. You decide on closed or open. This is where I change colors. Okay, don't do this all in the same color, this part. Okay, so there's no cement. It's not or equal to, so it's an open circle here. Okay, and then which way is it going? Okay, so this is where you read from the variable every time. So x is less than 4.1. Less than means left. Oops, I forgot to write my numbers, one bigger and one smaller. So 4.2 and 4.0 are just 4. Okay, so x is any number less than 4.1, but not including 4.1. Okay, so there's your process. All right, let's go ahead and look at example 2. Let's do a rewrite so we can do all our work down here. Make sure we write it properly. Greater than or equal to n minus 5. Okay, separate your workspace. And here we go. Okay, we just need to isolate the variable. So let's add 5 to both sides. That's nothing new. You should be a pro at that, right? And we have n is, we're reading from n, less than or equal to, different sign, subtract, -1. Okay, let's go ahead and graph it. Remember the steps for graphing. It says step 1, draw a line. Step 2, make 3 tick marks. 1, 2, 3. Step 3, write the target number. The target number is a -1. Make one number bigger, which is 0. One number smaller, which is -2. Now look and see, is there cement? Is it or equal to? Yep, there's cement, so it's a solid circle. So we fill it in, nice and bold here. Okay, and then we read from the variable every time. Okay, and it says n is less than or equal to. So less than means left. That's how you're gonna make sure you don't make a mistake with which direction to write the arrow. All right, let's try it out. If you want to pause, you can. or you can follow along. It's up to you. Let's go ahead and isolate our variable. So we need to add 2.3 to both sides. That crosses out. What are we left with? Well, we're left with x is greater than or equal to, different sign, subtract, 876, so negative 6.5432. Okay, and obviously you'd want to do that on a calculator if it's a test to make sure you don't make any silly mistakes there. All right, now that we have an x equals a number, or x is greater than, we can go ahead and graph it. So remember, step 1, draw your line. Step 2, write your 3 tick marks. Step 3, write the target number, which is negative 6.2. Okay, the next step is to write a number bigger to the right, smaller to the left. So bigger would be negative 6.1. Smaller would be 6.3. Okay, because it's negative. So just be careful with that. All right, now we look closed or open circle. Do we have cement? Yep, we got cement. So we're filling it in. We're including the negative 6.2. And then what do? We read from the variable. So it says x is greater than. Greater than means to the right. So there we go. Okay. Less than's always to the left. Greater than's always to the right. And then you're done. Okay. And so you could check it out. If you put any number in for x, it would be a true statement then. Okay, if you plugged it into the original thing. All right, so now we're going to go to the word problems, which is writing inequalities. These can only be tricky in the sense that it uses these phrases like is no more than, is at most, is no less than. So those are where it can get a little complicated if that confuses you some. So walk through that, but this is definitely a thing you may even want to screenshot and have in your camera roll, just as a backup thing to reference. Okay. All right. So when we have language like this, okay, you're going to have some sort of math problem. And so it says, for example, a certain semi-truck can hold no more than. So you have to pause and think what that means. If you're not allowed to hold any more than 25, what does that mean in real life? Well, can you hold 26 tons? No, it says no more than 25. So then ask yourself the question, can I hold 25? Yeah, you just can't hold more than 25, okay? And so we end up with this inequality, okay? And they tell you right here where the truck can hold no more than, which means it has to be less than, but it can be equal to 25 tons. Okay, so this is a truck holding no more than 25, and that's how that would look. So let's go ahead and take a look at example 3. It says Dylan can spend at most $18. Okay, so if we look here, we have at most, okay, which means less than or equal to. He can't do more than that, okay, but he can do that number, at most $18. So $18 is okay. And so it says, suppose the go-karts cost $5.50. We want to know, well, how many games can he also play? Okay. So we have the $5.50 represented as 5.5 plus any other games. But remember, it has to be less than or equal to 18 because it said at most $18. And that's what at most means. Okay, and then we could go ahead and solve. So let's go ahead and solve this one out to see how much he could play in games. Separate your workspace. It's a quick subtract the 5.5 from both sides to see what's left over. So x has to be less than or equal to 18 minus 5.5, $12.50. So think about what that means. It says, so the most Dylan can spend on games is $12.50. Okay, and so that's how you would write and solve an inequality to answer a question. So let's take a look at this one. You can pause and try it out and see what you do independently or follow along. I put the table down here as well to help. So Hannah's exercise goal is to walk at least 6.5 miles. Think about what that means. Okay, does she want to walk less than 6.5? No, she wants to walk at least 6.5. So the other question to think about is she okay with 6.5? Okay, or does she want to do more than that? Well, it says at least 6.5. So she's okay with 6.5, which means is equal to. It can include that number. Okay, she's already walked 2 3/4 miles. So here's what she's done so far. Okay, and we want to add another amount, but it has to get to at least 6.5. So the other amount can be any variable we want. I'll just use x. Okay, and at least, if you look over here, as at least means it has to get to greater than or equal to 6.5 miles. Okay, and so we don't have to deal with fractions. I'm just going to change this to 0.75 and this to 6.5. Okay, all right, so let's go ahead and solve this out. Separate my space, subtract 2.75 on both sides, and it'll tell us how many miles she needs to walk to meet her goal. And so we have x has to be greater than or equal to, and then we can go ahead and do our 6.5 minus 2.75 equals 3.75 miles. Okay, so determine the distance Hannah needs to walk. Hannah needs to walk at least, notice I'm using the same language as up here, 3.75 miles. Okay. All right, let's go ahead down to example 4, and that's it for our notes. Okay, so they're giving you just another example first. So Caleb owns 2 types of dogs. This is subtraction. I'm just going to right up front tell you it's a little bit trickier because you have to pay attention to the order in which you subtract. So pay attention to the order in the actual word problem. The difference in height of his Yorkshire Terrier and his Great Dane is at least 25 inches. Caleb's Yorkshire Terrier has a height of 6 1/4 inches. So the thing you have to be aware of is obviously to find the difference in height, we need to do the bigger dog minus the smaller dog. In this case, we know that the Great Dane is the bigger dog. Okay, and so that's going to go first. So we're going to have the Great Dane's height minus the Yorkshire Terrier's height must be at least 25 inches. So think about what at least means, okay? Or you could look, at least means greater than or equal to. So let's go ahead and we have it set up here. So we have h minus 6 1/4 because we're finding the difference, and difference means subtract, has to be greater than or equal to 25. So let's go ahead and separate the workspace and we can solve this out. So isolating the variable, 6.25 plus 6.25, that cancels out and we're left with h is greater than or equal to, we have 25 plus 6 is 31.25, okay, and that's height in inches. And then make sure that makes sense. So this means the height of the Great Dane, that's what h is. The height of the Great Dane must be greater than or equal to, okay, 31.25 inches. Okay, so that the difference is at least 25 inches. It can be more, but it has to be at least that. Okay, all right, let's go ahead and it does say interpret the solution, so let's answer the question. The possible height of the Great Dane, so the possible height of the Great Dane must be greater than or equal to 3.125 inches. Okay. All right, let's try it out here. You can pause if you want or follow along. Gabriella paid $17.25 for a sweatshirt that was on sale. Okay. The difference between the original and sale price. So I know this is my bigger amount. This is my smaller amount. So something to be aware of. The difference was at most $8.50. So try to think about what inequality that at most is. Okay, so at most means it's the most, which means everything else has to be, it had to be less than that because it can't be bigger than 850. Is it allowed to be 850? What do you think? Yes, it says at most 850. So that's a less than or equal to. Okay, and if you weren't sure, you could look at most, you can see right here. Okay, all right, so let's go back to the problem. Okay, we know the difference means subtract. So they're giving us the, let's see, she paid $17.25 for a sweatshirt that was on sale. So that's the sale price. So we have X minus the sale price. So that'll give us the difference. And we said at most, so it has to be less than or equal to $8.50. So let's go ahead and separate the workspace. And we need to isolate the variables. So add 17.25 to both sides. Okay, and we have X has to be less than or equal to, let's go ahead and add it up, 17.25 plus 850 equals 25.75. Okay, so that difference between the original price and sale price, the original price has to be less than or equal to $25.75 to be at most $8.50. All right, so write and solve it. Interpret the solution basically means answer the question. Determine the possible price of the sweatshirt. Okay, so the sweatshirt was, and now we're going to say less than or equal to $25.75 with a money sign. Okay, so there we go. Or you can say at most, so that you're using that language back up in the problem. Okay, all right, and there's your official answer. Okay, so I'd say the at most would be the better choice than to use a symbol in your word problem. But all right, let's go ahead to your homework, which is 7-6 practice homework. We'll just do a couple here so you have some examples, and then I want to give you practice with the rest. Okay, so a couple to be aware of. Let's do, we'll go ahead and do one on the number 1 and 2 because those are two different inequalities. So it's a quick solve here. We're going to go ahead and subtract 8 on both sides. I'm going to keep it pretty small here. Okay, so that goes away, and we are left with X is greater than or equal to, and then you can go ahead and do your 14 minus 8, which is 6. And so we have X is greater than or equal to 6. Now, they already wrote a really big number line for you. Okay, so there's my target number is 6. Okay, so the next step, they already have a number bigger and number smaller. So I'm going to put my tick marks there just so I have the same habit as before. Okay, so now read from the variable. I'm going to write that again just so you remember. It's really important. So X is greater than or equal to. So is there cement? Yep, change colors. So I'm going to go like this, and I'm going to fill in the circle. X is greater than means go to the right. So I'm going to shade this in and just make a little arrow that way. Okay, so there we go. We've solved and graphed. Okay, all right, let's go ahead and do number 2. So another quick solve here. Isolate the variable. I'm going to write it pretty small so I have room. That goes away, and we're left with X is less than. This is a same signs add and keep. So 5.4 plus 1.6. We have 5, 6, 7. So a negative 7. Okay. Find your target number. One big, one small. Okay, and then look and see about the cement. There is no or equal to. So x is less than -7. There's no cement, so it's an open circle. Read from the variable. It says x is less than, which means arrow to the left. And that's what that should look like. Okay, so you can do the rest of them to practice those, and then we'll look at those the next day. All right, and then let's go ahead and take a look at some word problems. These are a little bit trickier in the sense of the order. Okay, so let's go ahead and just explore these ones together. Okay, so that you're attacking it the right way. A dolphin is swimming at a depth of -50 feet. So that's its current location. And then it ascends. So remember, we have ascends and descends. Ascend means going up. Okay, a certain number of feet. That's obviously our variable. Okay, so we could use f or whatever. I just like to use x. Okay, so it's going up a certain amount of feet to a depth above -35. So what does above mean? Does it include -35? Nope. It has to be greater than. Okay, so let's go ahead and set up the inequality. So it says we start at -50 feet. Okay, and then we go up, which would mean addition, a certain amount of feet. So I'm going to do my x to a depth above -35. Okay, so then you need to go ahead and solve that and write the answer. Okay, determine the number of feet the dolphin ascended. So the dolphin ascended at least how many feet for that to be true. Okay, so you need to finish that one. Okay, let's look at number 8. Linda had 2 cats. All right, Linda. The difference in weight of her Maine Coon and Siberian is at least 6 pounds. Okay, Linda's Siberian had a weight of 8 3/4 pounds. So we don't know a Maine Coon and a Siberian. We don't know which is bigger or smaller. And so we're going to go with the order that they gave of the Maine Coon versus the Siberian. So Maine Coon minus Siberian. Linda's Siberian has a weight of 8 3/4 pounds, and we know the difference is at least 6 pounds. Okay. Determine the possible weight of the Maine Coon, then interpret the solution. Okay. So let's go ahead and set this up. So we have the Maine Coon minus the 8.75, we'll get rid of the fraction there, is at least 6 pounds. So what does at least mean? You may need to go back to your notes, okay, and go to that table and think of at least. So at least means greater than or equal to, okay? So it's okay to go back to that, okay? So at least 6 pounds, okay? Then you can go ahead and solve and see what the possible differences could be, and then write an answer to the question, okay? So don't just leave it at x is greater than or equal to. Make sure you actually write a sentence answer. All right, let's go ahead and look at number 9. The difference between the monthly high and low was less than, well, that's pretty nice, that's easy, less than 27 degrees Fahrenheit. They're telling you the monthly low was -2. Determine the possible monthly high. Okay, so we know we would do high minus low, and so high minus the low. So the monthly low temperature was a -2. So look, you're doing high minus low. Don't do x minus 2. It's x minus a -2. And you know that that's technically x plus 2, but we'll leave it as is for right this moment. And it said the difference between those has to be less than 27 degrees Fahrenheit. Okay, so let's go ahead and actually try this one out. Okay, so because we have this, I'm going to KFC, and we really have this, right? So we're going to subtract 2 from both sides, and then we end up with x is less than 27, 26, 25, 25 degrees. Okay, so x must be less than 25 degrees in order for this to be true. Okay, All right, let's go ahead and answer the question because it says interpret it. So determine the possible monthly high temperature. Okay. The possible monthly high had to be, and you can use, instead of using the symbol in here, use the language, okay? Less than 25 degrees Fahrenheit, okay? All right, so there we go. And then let's look at the last one. There's nothing on the second page. Teddy has 2 piggy banks. The difference in the amount of the money between the 2 banks is no more than $10. Think about what no more means, okay? I want you to try to do this one on your own. One piggy bank has $7.31 in it. Determine the possible amount of money in the other piggy bank, okay? So we'll set up the same thing of your x, okay? We're talking about difference is less than, or sorry, x minus something, and then figure out what the inequality is for this one. So try that one out on your own, setting up the the inequality. It's basically the same as an equation, but we call it an inequality because it's not equal to. So go ahead and you have all those to finish. Don't forget to finish 7, 8, and 10 as well. I just got those started for you, that's all. Okay, if you need help, let me know, but good luck.